Okay, Year 11 A-level students. So for question 1, some of you did expand the entire thing, and you can do that. That's not, there's nothing wrong with doing that. However, if you only focus on the x cubed term instead of the x term or the x squared term or the x to the 4th term or the x to the 5th term, there are 9 possible ways of multiplying out each of the terms within each bracket. We're only interested in those that are going to give us x cubed terms. So we could do the 3x squared times the minus 2x term. That's going to give us an x cubed. And we could do 4 times the x cubed term, and that's going to give us x cubed as well. These two are going to come out as minus 6 and minus 4x cubed respectively. So the answer is minus 10, because minus 10x cubed is the term. We don't need any of the others. If you do the working, you don't get marked down for it. However, you don't need to do it. It's only 2 marks. So that's what I want you to know. Next, expand and simplify. The big error to make here is to miss the negative, turning this sign positive. Expanding it and simplifying gives you 22x squared plus 2x. Okay, next question 3. This is one of the more difficult questions on the paper. It's very easy to get confused with the rules of indices if you don't write down clearly what this means. 2 to the power x times by 2 to the power 3. That is where you need to be crystal clear in your working out, and then you change 2 to the power of x to y and 2 to the power 3 to 8, and the answer is 8y. Question 4, very GCSE this one. We're taking the power of 1/5 inside a big bracket. 32 to the power of 1/5 is the 5th root of 32, or 2 to the power of 5 is 32, so that number inside the bracket really is 2, and the answer is 8. Okay, question 5 now. First thing we do is divide by the coefficient of x. That thing in brackets in front of x, that's the coefficient. And we start by getting our fraction. Now we need to rationalise the denominator here. So we multiply by the denominator with a sign change. When we do that, the denominator can be expanded using dots. Difference of 2 squares, and we expand the top in the usual way. So the denominator becomes minus 1. The numerator is 17 minus 8 root 5, and by dividing through by minus 1 we change the sign of both terms at the top. And the answer's on the screen now. Okay, question 6. The trick here is you don't actually need to complete the square, it's been done for you. So completing the square has been done. We're testing, can you solve from this point onwards? You need to move the 2 over. In particular, I'm looking for the plus or minus when you square root, and then adding the 5. Gives us these 2 solutions. Okay, we're moving into question 7 now. Question 7 is a devilishly difficult question, and it really tests your ability to remember and recall how you do some of the basics, but with nasty values for A, B, and C. So the first thing you need to figure out to find the horizontal distance is that you need to solve this equation. It is going to be the point at which the path crosses the x-axis, which is ground level. So any method to solve that is good enough. You will get 2 solutions. The solution that is positive is the one that you want. So if we wrote our solutions in surd form, it would be something like 100 plus or minus 10 root 109. Something like that. And if we take the positive version of that, it comes out at 204 metres with a few decimals to go. However, that's the answer. The negative one is about -5, -4, -5, and we're not interested in it because it's a negative value. With reference to the model, interpret the significance of the constant 1.8 in the formula. Well, 1.8 is the value of C, and you can see it up here. So when D is 0, that is the height above the ground. So at the start of the motion, before the the arrow has been released, that is the height above the ground. So you could think of it as the position of the arrow as it's being fired above the ground. Okay, so in effect we need to complete the square on this. What makes it difficult is completing the square on this is actually quite tricky with the numbers you've been given. So taking the negative 0.002 out of the two terms with d squared and d in, this is what we get. We then complete the square within the brackets, halving 200 to get 100. And we take away 100 squared, but that all sits within the outer two brackets, with 1.8 sitting outside again. Now if we expand in, the outside term minus 0.002 times by the squared bracket, that's really easy to write down. We now also need to multiply it by negative 10,000, which should come out as positive 20. And then adding the 1.8 and rearranging into the order that you see asked for in the question. A is 21.8, B is 0.002, and C is 100. Okay, now the reason we've done this is because when it gives us the maximum and the minimum points. So if we want to know the maximum height above the ground, that is when D is equal to 100, the maximum height is going to be that 21.8. That's what the 21.8 stands for. It is the maximum height, and it came straight from completing the square. And the maximum height is going to be achieved when the squared bracket is equal to 0, and that requires D equaling 100. Those are only 1 mark each, but for me they're quite tricky, and part C was the most difficult. Okay, so here we are factorising using Mr. Hubbard's slightly unusual method for factorising. That's it. Those are the 3 marks. Find the coordinates of the stationary point. Secretly, I wanted you to complete the square. You can differentiate, which you have covered in GCSE, so you can do that. And you can find the stationary point by doing that. Otherwise, this method is perfectly valid, and I want you to have a look at it, particularly if you did differentiate and make that equal to 0. The stationary point, remember, is the maximum or the minimum. In this case, it's a minimum. Y has a minimum value of minus 16, and that happens when this bracket is 0, i.e. when x is equal to minus 1. Okay, this is one of my favourite types of questions. You take one quadratic in x and you turn it into a second quadratic in k, which actually ends up being a quadratic inequality, which you do know how to solve. However, it's just the structure of these questions can be quite tricky and challenging. So the first thing we're doing is identifying A, B, and C as the coefficients of x squared of x, and we say it's the coefficient of 1, so just the constant left over. We substitute that into the discriminant formula, and that has to be negative if we have no solutions. Now, if we do all the maths, this is what we end up with. Remember, if you divide by a negative, you would have to swap the direction of this arrow. If you did that, that was a mistake that I saw in a few people's work. I'm not going to divide by a negative, I'm going to divide by positive 4, and I'm going to factorise. There was certainly a lot of people getting to these sorts of steps with quadratic inequalities and not doing the sketch. I'm going to be perfectly clear. If you don't do the sketch, you will always get it wrong. You will always lose the marks, so always do the sketch. I'm not a draconian teacher, I'm just telling you what works. The sketch works, it's quick, you need to adopt it. When you sketch the graph, make sure you mark on the 2 roots and you are shading below the line because you are looking for negative values of your y coordinate. It gives you the correct answer with the correct inequality signs in the correct places. People were finding -1 and 4/3. There were a lot of mistakes and it was all due to not sketching. Okay, this question managed to con a lot of us. It was literally you were just finding the coordinates of P and Q and nothing else. You weren't finding the area, you weren't finding anything. So do make sure you read the full question. Sometimes I have to abbreviate questions from full exam questions to make them make sense. Anyway, we go through and we solve these 2 equations simultaneously. This is probably the most common way of doing it. Again, my funny factorising method with ax over a, and we take out factors, and we are done. And once we find our values of x, it's being 5/3 and 1/4, it's easiest, in fact it's very sensible to be using the linear equation. Not only is it easier, but it will always give you one value and that value will always be correct. If we don't and we do it with the other equation, it's quadratic. It could give us 2 values and we might not know which one to take. Okay, so the y value associated with 1/4, x equals 1/4, is 17/4, or 4 1/4, 4.25, obviously acceptable. Well done anyone who got full marks on this. I think C in particular is nasty, so if you managed to get there, well done. A, I felt was pretty easy. Errors included, some people are very familiar when you do a division with 8 and 2 to get 4, because 8 divided by 2 is 4. However, in this case, you are dividing by 8, and you need to be really, really on the ball in these last steps. Dividing by 8 means 8 goes into the denominator. There were mistakes where x was greater than 4 came into it. For B, we need to factorise and sketch. Again, this was coming up again. People not liking sketching, you've got to bypass whether you like sketching or not. It's useful, so it's more important than being liked. And we get our factorised quadratic. We are greater than 0, so we're going to sketch that and shade every part of the curve that is above the x-axis. We need to put on our 2 roots, x equals 1/2 and x equals 3. We sketch and we shade above. Finally, if we mark our solutions for A and our solution for B, that's 2 solutions. It looks like there are 3 inequalities. There are not 3 inequalities. There are 2 separate solutions. And you are looking for the values of x, which satisfy both A and B. I'm drawing them in colours so that you can see what's going on and on the same number line. So I'm looking for the numbers which are on both the red solution and the blue solution. I'm scribbling that in green now. So what I want to do is think about the numbers between 1/4 and 1/2 and greater than 3. And that's my solution. Again, almost nobody writing this out on a number line. Absolutely is vital that you visualize this and you give yourself the opportunity to see where this is. There was one really unfortunate soul who didn't extend their lines out long enough. Extend them out all the way to the edge of the paper if you need to. You need to see where there's going to be 2 copies of the line and you can show them. At the bottom, we've written them out in inequality form. If you were using set notation, that would be useful. Colon, the X at the start, and those funny wiggly brackety lines. That's the set notation version of it. I did not mark you down just for writing it as inequalities. You wouldn't for this. The values of X, where X is according to those inequalities, is good enough. Okay, guys, make sure that you've marked up your test and you've checked through any questions that you haven't got right.